Before we get started today, then it's worth me pointing out to you that we have actually finished P4 in our last lesson together. So that means that we're now actually going to be able to do our end of topic assessment, which again I've put on Shobi. So the class code for our physics class is 3W3CJ. So go on there, download it, actually work through it, answer it in Word, save it, re-upload it for me so I can give you some feedback. And as always, even if you're not in my 10W class, if you want to submit this for me to do some marking for you, then by all means you are welcome to do so. The deadline for that one is going to be the first Friday back after half term, which I believe is the 5th of June. So go, get it, download it, answer it in Word, save it, re-upload it for me. Hi everyone and welcome to the internet. So what we're going to be doing in our lesson today is having a look at atoms and isotopes. So hopefully by the end of this lesson you're going to be able to describe atomic structure, which should be a nice recap on some of the work you did in your earlier chemistry work, and be able to define what isotopes are. And again, you did look at this in one of the early chemistry units. So to start us off, first of all, we've got 3 questions on our screen there. I'd like you to have a go at answering those in your book for me. So I'm just going to give you about 3 minutes to have a go at that. Okay, let's check those answers then. So hopefully your structure of an atom diagram looks like the picture at the top. So in the center we've got our nucleus made up of our protons and our neutrons, and then in those shells around it we have the negative electrons. So the three subatomic particles for number 2 are proton, neutron and electron. Tick these if you're getting them right, of course. And then our third question, the top number is the atomic number there, the smaller of the two in the box. The 2 letters is the symbol. The name is obviously the element name. And then the number at the bottom there, 6.9, that is the mass number as the larger of the two in that box. So add up your score and let me know how you did in the chat window. So, starting us off today, let's think about what I hope is a really simple question to answer. What happens if you put ice in water? So real quick, just write me a sentence to explain what happens to the ice when you put it in water. I'll give you just 30 seconds to do that. Now, what I'm guessing you've written down is that the ice floats. So if you got that, give yourself a tick at this point. However, it's not quite as simple as that. What we can see in the picture on your screen at the moment is the glass on the left, we've got some ice floating, as we would expect. But in the glass on the right, we still have ice that's still made of H2O, but it's sunk. So see if you can suggest why some ice sinks. So I'll just give you 30 seconds, see if you can come up with an answer to put into your book for me. Now, the reason that some ice will sink is because it's made of a substance called heavy water. Now, hopefully we know from the periodic table that hydrogen normally only has a proton in its nucleus, no neutron at all. But there is a different form of hydrogen that has both a proton and a neutron in its nucleus. So if that hydrogen is used to make the water molecules, then when it forms ice, it sinks. So I'm hoping you've already got this diagram of the atom from our starter. If you haven't, then draw it in your books now as a good reminder of where those particles are and how they're arranged. What I want you to do once you've got that diagram done is I want you to create me a table in your books that shows the relative mass and the relative charge on those subatomic particles in the atom. So you're going to have your proton, neutron and electron. I want to know the relative charge and the relative mass on each of them. So I'm going to give you about 3 minutes to get that done. Okay then, let's check our answers. So hopefully we've got a table that looks something like this. So we've got our three subatomic particles, proton, neutron and electron on the far left there. Then we've got our relative mass column and then the relative charge column. So if we look at the proton first of all, that has a relative mass of 1 and a relative charge of +1. And remember, when we're talking about these relative masses, then it's relative to a proton. For our neutron, we've got a relative mass of 1 and the relative charge is 0. So neutron, it's neutral, there is no charge, hence 0 there. Then our final one, the electron, this is the one with a very different relative mass. You can see there it's 0.0005. So make sure you've got the right number of zeros after your decimal place. You can also describe that as 1/2000. That's also acceptable. In terms of the relative charge on an electron, it is -1. So when we're writing the relative charges, do make sure that for the proton you put the plus sign in front of the 1, and for the electron it's really important to have the minus sign in front of the 1. So make sure you know the relative masses and relative charges of those three subatomic particles, because this is something that's going to come up not only in your physics but also in your chemistry. So it's a 2-for-1 learning opportunity here. If you haven't got that table finished, then hit pause and get those done. I will leave it up there for about another 10 seconds, but if you need more time, as I say, pause the video. Okay, so what I've got for you here then is a part finished sentence, and I want you to finish that first sentence, and then 3 questions I want you to have a go at answering. So I'm going to give you about 3 minutes to put that first sentence with its finish, and then answer those 3 questions in your books. Off you go. So for the questions further on down, you will need access to a periodic table. If you haven't got one, then there are links on my website, so you can pause the video here and grab a periodic table to help you out. So let's check our answers then. As always, tick it if you got it right. If you need to correct it, then please do so. So the charge on the nucleus of an atom is determined by the number of protons within it. So if we think back to what we said about the structure of an atom, then the nucleus is made up of protons and neutrons. So protons have a relative charge of +1, neutrons have no charge. So the charge on our nucleus will be the number of protons, and it will always be a positive charge. For our second question there, what element has a charge of +1 on the nucleus? This is just look at the atomic number 1, okay, which on our periodic table is hydrogen. Next question, what element has a charge of +79 on the nucleus? Then that's the one with the atomic number of 79 on the periodic table, which is gold. And then finally, what is the charge on the nucleus of an atom of arsenic? So we find arsenic on the periodic table, we look at the atomic number, that's 33, so the charge must be +33 on the nucleus, because it will have 33 protons, each one with a single positive charge. So count them up. Who got 4 out of 4? Who got 3? Who got 2? Who got 1? Hopefully no one got 0 today. Let me know in the chat window. So next question for you is I want you to write a definition for the term isotope. And again, this is something you have done in one of your early chemistry units. So in your books, what does isotope mean? Okay, let's check those definitions then. Obviously, if you don't have this definition, please write it in your book, highlight it, put it in a box, something to make it stand out. Again, this is a 2-for-1 deal. You learn this now, you've got it for your chemistry as well. So an isotope is an atom with the same number of protons and electrons, but a different number of neutrons. So this could very well be a 2-mark question for just writing a definition of isotope, because you can get that first mark for saying it's got the same number of protons and electrons, and that second mark for a different number of neutrons. So make sure you know that definition. I'll just leave it up there for about another 20 seconds so that you can write it down if you've not got it already. We know that when we're talking about an isotope, this is something with the same number of protons and electrons, but a different number of neutrons. So what I want you to do is have a go at answering these 2 questions in your book. First one, what impact will this have on the mass number and the atomic number? And secondly, what impact does it have on the charge? And explain your answer for that second one. I'll give you about a minute to have a go at answering those in your books. Okay, let's double check your answers for this. As always, tick it if you got it right. If not, write the correct answers in for me. So the impact on the atomic number, first of all, is nothing, because the number of protons doesn't change, therefore the atomic number does not change. For the mass number though, because the number of neutrons is changing, then that will change. In terms of the impact it has on the charge, then nothing, again, because the only thing changing is the neutron number. And because neutrons have no charge, then we won't see a change in the charge overall. So let's look and see what this really looks like in practice. What I've got for you on your screen there are the three different isotopes of carbon. Carbon-12, carbon-13 and carbon-14. So when we look at it, and we'll look at carbon-12 and 13 first of all, then they both have an atomic number of 6, because remember, the atomic number does not change. So carbon will always have an atomic number of 6. The mass number though, that's the bit that's changing. And we can work it out by looking at the name. So up the top where it says carbon-12, then the 12 is the mass number. So obviously the mass number for carbon-12 is 12, the mass number for carbon-13 is 13. Then underneath we've got the number of protons, electrons and neutrons. So the number of protons and electrons is just the atomic number. So for carbon-12, atomic number is 6, so the protons is 6, the electrons is 6. Now to work out the number of neutrons, we've got to do the mass number minus the atomic number. So for carbon-12, that would be 12 minus 6, which hopefully we know leaves us with 6. So we have 6 neutrons. If we do the same thing for carbon-13, we've still got 6 protons and 6 electrons, because the atomic number is still 6, it hasn't changed. But the mass number is 13 in this case. So we need to do 13 minus 6, which gives us 7 neutrons. So I'm just going to give you about another minute to have those jotted down in your book, and also have a go at carbon-14 for me. See if you can fill in the blanks for carbon-14. Let's just quickly double check we've got these right. So tick them if they're right as usual. Atomic number for carbon-14 should be 6. The mass number is 14. The number of protons 6. Number of electrons 6. And the number of neutrons should be 8. Let me know how you did in the chat window. Did you get 5 out of 5, 4 out of 5, 3? Give me a number over there now. So let's have a look at the kind of question we could get for this then. Calculate the number of protons and neutrons in an atom of radon 222. So what we've been given there is the symbol for radon, Rn. We've got the mass number and our atomic number. So we're being asked to work out the number of the protons and neutrons. So we'll do the protons first of all. Now, when we're coming to look at the protons, sorry about my handwriting, then what we need to do is look at these two numbers here, and what we need to work out which is the atomic number. And hopefully remember the basics from our chemistry that the smaller of these two numbers is the atomic number. So 86 is smaller than 222, so that means 86 is the atomic number. And the atomic number quite simply tells us the number of protons, so we have 86. Then, to work out the number of our neutrons, then what we actually need to do here is subtract. So if we remember what we've said previously, our mass number is the number of protons plus neutrons. So that's the total number of all of the neutrons and the protons together. Whereas our atomic number is just the number of protons. So if we actually do this, so that we are going to have our mass number minus the atomic number, then we substitute in. So our mass number in this case is 222. We're going to take away the atomic number of 86, and of course you don't have to do this in your head because you are allowed a calculator in every single science exam. So 222 minus 86 gives us an answer of 136, and that is our number of neutrons. So that's all we actually need to do to calculate those. Okay, your turn to have a go. So another question is on the screen. Have a go at answering this in your book. Don't forget, show you're working. I'll give you a minute with it on the screen to have a go. Let's make sure we've got that one right then. So calculate the number of protons and neutrons in an atom of uranium-237. So first thing we can do is write down the number of protons, because that is just the atomic number. So remember, the atomic number is always the smaller of the two numbers, so in this case 92. If you got that right, give yourself a tick. Then to work out our neutrons, it's the mass number minus the atomic number, which would be 237 minus 92. Give yourself a tick if you got that bit. And that will give us an answer of 145. So give yourself a tick for that. Add them up, let me know who got 3, who got 2, who got 1. As usual, let's finish off with our plenary questions. So any of you working up to a target grade of a 5, it's the 2 columns on the left, so the up to and the grade 5. And for those of you working at target grades of 5 or above, then you can do the grade 5 and up columns. So I'll leave those up there for about a minute for you. If you still need a bit more time to finish those off, then hit pause on the video now. As usual, the answers to our plenary questions can be found over on my website. The link is on the screen. Hopefully you found today useful, and I look forward to seeing you again on Wednesday.